Hi, I'm David Anderson. I'm the Director of Technology and Solutions Marketing for vArmor. And today I want to talk to you about vArmor's solution for microsegmentation and how we're different than the traditional model of software-defined networking and the utilization of service chaining in order to achieve security in the data center. So let's start out by talking about kind of what a service chain is and why it's needed. In this case, we have an SDN kind of controller. And the controller is kind of the policy engine behind our SDN network. That's how we do our traffic steering, our policy definitions for how traffic flows within the architecture. And we have a couple of workloads here as an example. So we have, let's say, a web server. And then over here we have a database server. And I need to communicate between my web server and my database. And so in this case, I've got traffic that I want to occur between these two over maybe using SQL traffic, right? So let's say over port 1433. And how do I allow that traffic? Well, I set up a policy in my SDN controller, for example, in my controller that allows me to define and open layer 4 ports once I've done my basic networking policy so that I can allow communication between my workloads. Now, this is a layer 4 port that gets opened for port 1433. And I'm allowing all that 1433 traffic, my SQL information or my SQL calls to go between my web server and my database. Now, the first problem with this is that I am basically opening a port and I'm allowing anything coming over that port. I'm not doing any inspection. And what we mean by that is we're not doing any stateful inspection to know exactly what's happening within that port. I'm opening this port, but there's no guarantee that that's actually SQL traffic. There's no guarantee that it's actually legitimate SQL traffic. So it could be a SQL injection attack against my database here. And if that happens, I'm kind of blind and I really don't know what's going on. So in order to solve that, maybe I want to send that traffic through a stateful firewall and do some kind of application layer inspection. And this firewall can be physical, could be a physical appliance, it could be a virtual firewall that's based on a physical appliance. But I kind of have it as available as a service. Now, I need to figure out how to get traffic to that firewall. And to do that, I use my controller to define something called a service chain. All right, and that service chain could be one or more firewalls, it could be other services as well, but the reason that I have to really create this is because I have a firewall that's separate kind of from my SDN fabric, and I have to be able to get traffic to that firewall in order to accomplish the security policy enforcement that I would like to for, in this case, my SQL traffic. So I need to redirect traffic from my web server through this firewall up to my database and back, right? Because if it's a stateful connection, I need to see both sides. Otherwise, I don't know if that is a legitimate connection. So how do I do that? Well, I define on my SDN controller that I want to redirect my layer 4 port of all my 1433 traffic from here to here. So now I'm sending all of my 1433 traffic through my firewall for stateful inspection for SQL. So I want to make sure it's kind of legitimate SQL traffic, that it's not doing anything weird or malicious like SQL injection attacks against my database. And I do all of this, and now what if I have another service that I want to add behind here? What if I have, let's say, another database? I have another database that sits back here. Or I have another web server, another app server that I've created that needs to communicate between those two, that maybe is using a different port and a different protocol. So now I have to define that as well. And let's say that needs to flow between here. I have to create another mapping, right? Or if this is an app server, let's say, instead of a database, and that's an app-to-app communication or web-to-app, doesn't matter, right? I can use multiple different ports and protocols between all of these, and I have to define them so that I actually get that traffic redirected through there. So now I've kind of hit a first pain point that we want to kind of talk about and summarize here. One is that it's very complex in order to implement this security policy through this idea of service chaining. And because, number one, I start to figure out, wow, how can I forward traffic through my firewall? Okay, I figured that piece out. How do I decide what to forward through the firewall versus what not to forward through the firewall? And so it becomes a little bit complex trying to just define the policy that you want to set up and define how you want that traffic to actually be steered through this entire architecture. And we do that, right, once again through that service chaining, but it becomes very complex to manage that. Now, the other problem is that once I start steering this through this firewall, remember, if we're talking about a virtual firewall, for example, this is about a 1 gig limit on that virtual firewall. And once I hit that, I need to spin up another firewall instance and maybe another firewall instance. And then once I do that, I need to start, once again, service chaining traffic through these. So I have to kind of figure out how I want traffic to flow through these and how I want to balance it across them and how I actually want to divide that traffic. So now I've got multiple firewalls, I've got multiple service chains. I'm trying to figure out which ports to send to which firewall, firewall 1, firewall 2, firewall 3. And it becomes pretty complex to manage. And the reason that this occurs as well is because I've got performance limitations, right? So I've got some scalability issues here. And not only scalability for virtual firewalls, but I have the same problem if this was a physical firewall, where I hit the physical limit of the firewall, and now I have to go get another physical firewall and rack it and tie it into my service chain architecture. So it becomes very cost prohibitive as well if I go with a physical appliance. So this is kind of a very performance limited design. I've got very complex policies set up to figure out how and where to redirect traffic. And then I've got to figure out how I redirect traffic if I have a failure. Between one firewall and another, I've got to have some HA in there, which means maybe additional firewalls in some cases. And now I've got a very complex environment, not only to try and manage and try and put in place to begin with, but I've got a very complex environment to try and troubleshoot to figure out to make sure that I don't have asymmetric flows and to figure out where the problem is if I do have some type of application communications errors, or if I break an application, I need to really dig in and try and figure out where those flows are being dropped. So with all that in mind, there's also a third concept here we want to talk about is just kind of limited security. And what I mean by that, and we kind of alluded to this earlier, is that if I'm just doing layer 4 inspection, I don't really know what exactly type of traffic is coming over that port. It's using the port, but I don't know if it's legitimate. And I can't really send every bit of traffic through my firewalls because it becomes cost prohibitive and it's very hard to troubleshoot and it's hard to scale. So I kind of have to figure out what's good enough for L4 inspection, what's good enough for firewall, application layer inspection. But an example of this would be if I'm an attacker and I just use a well-known port, like port 80, port 443, port 1433, or a telnet port like port 23, all of these different ports, right? If I'm just opening those and allowing those, I can basically inject whatever I want over those ports and send them down to a database, an application server. I could compromise a web server and then send it over a common port to a database or an app server. Basically, I have very limited security because now I'm kind of going back and forth between this architecture as to what is good enough to kind of let through and what I really need to inspect at a deeper level. So I have to make those decisions, and it becomes a very limited security model. On top of that, I've got this firewall that's kind of giving me that information, and I'm creating syslog traffic off of that, and I'm able to kind of correlate some of that on a SIM. But I have no integrated analytics. So I'm not able to correlate all of this information that's coming across these without creating another component within this that adds more complexity so that I can see and figure out what's happening in this environment for my network traffic, my applications, my users, and being able to map all that stuff together. So it becomes very complex. So now let's talk about vArmor's approach to creating this distributed security architecture and microsegmentation in this environment where we don't require service chaining. So let's take, for example, we'll take our web server again. And we have a database server. Now let's just imagine that for an example, that kind of ties back into our previous one, that this web server is on a hypervisor, and this database is on another hypervisor, and those guys kind of go up to my top of rack switches again, and it feeds into the rest of my network. All right, so we have that kind of architecture built. But now let's talk about how we insert this notion of an enforcement point on each one of these hypervisors. And then I create that distributed security fabric that kind of goes between hypervisors. Now, what happens in this model is that my web server and my database are both connected to the vArmor enforcement point, and every flow and all the communication between the two automatically goes through these enforcement points. And we've talked about this in previous videos if you've watched, where I'm able to look and get full visibility into all of those traffic flows that are going across those enforcement points, and then I can apply policy to those. That policy includes things like microsegmentation. So I can microsegment these workloads out and isolate them based on all of that information I'm learning through these enforcement points. I can also apply policy natively. And that's important because I can now do L4 to L7 policy within my enforcement points for my database and my web server. And if you really look, this is important because I'm now able to do all this natively, and because everything is sitting in line and I'm passing all of my traffic through these enforcement points, there's no reason for me to redirect traffic through a service chain to each one of these. If pain point number one was complexity, we're going the opposite direction and we're looking at a simple architecture, right? We want to create a simple way for customers to go out there and design security and implement security in their virtualized data center and cloud. However, let's say that I also have maybe, I still have an SDN controller, maybe sitting up here somewhere. And my SDN controller is still automating a lot of my compute and network and security platforms across my data center so that I can create a lot of automation within the environment. I can still do that, and I can still integrate with SDN. I can spin up additional enforcement points across different hypervisors as I need to. I can create security policies that actually tie back to my network and my compute orchestration services. And I don't have to do service chaining now to redirect any of those flows as part of that policy because everything is natively going through the enforcement point on each hypervisor. Now let's talk about pain point number two, which is scalability. So in this case, we have our enforcement points on each hypervisor, which was different than our old model, right? Where we had this idea of a firewall and we had to service chain everything together. And once we reached the limit of the firewall, we had to spin up another instance. In this case, our enforcement point is native within each hypervisor, and it scales to multi-gigs per hypervisor for layer 4 and layer 7 policy enforcement with application-based microsegmentation. So now I'm able to do all of this natively. I'm able to scale to multi-gigs, and I'm able to scale this fabric out, this distributed security fabric that we've been discussing, to over 100,000 workloads across my infrastructure. So that helps me address my scalability concerns. Number one, I can do multi-gig layer 4 to 7 policy enforcement. I can do that with microsegmentation enabled. I can do it up for 100,000 workloads across my infrastructure. And I can also tie into an SDN controller where I can orchestrate and automate a lot of this process along with the rest of my network capabilities. Now the fourth one is around limited security that we discussed earlier as a pain point. So in this case, we look at the enforcement points and kind of what they're seeing. Well, number one is they're seeing all layer 4 to 7 traffic that kind of flows through this environment. That gives me full visibility into what's happening to and from these workloads as well as between these workloads. So everything that's coming in and out of this environment, right, as well as between, I'm getting full visibility on. It doesn't matter, I don't have to redirect, I don't have to just make a decision based on a port in order to see this information. I'm seeing all of it natively. So once I do that, I can create that policy based on that information like we talked about. So I'm getting full visibility for stateful information for layer 4 to 7 across all of this infrastructure. That allows me to also see threats. So if I see things that are happening here where maybe I have someone attempt to do lateral movement, maybe somebody goes in and runs an exploit against a web vulnerability on my web server, they inject a SQL injection attack against my database, or they attempt to, I'm seeing all of that because all of that traffic is going through my enforcement points, and I'm able to look at those threat details and I'm able to correlate them with analytics, right? So I have my analytics platform that's also integrated into this. So I'm getting full context for all of my network, my user, and my application flows, and correlating all of that against the threats that I'm seeing, and I'm able to update policy based on that information. So now I'm getting full security for all applications that are flowing through this infrastructure, not only within this kind of SDN private data center architecture, but also out in, we talked about this earlier, kind of out in my public cloud as well. So if I'm out in AWS, for example, I can do the same thing where I'm deploying these enforcement points out there, and I'm actually looking at all of the traffic and protecting all of my Amazon instances that are out there being spun up in the cloud. So with vArmor's distributed security system, we get a simplified method to be able to do microsegmentation, layer 4 to layer 7 policy enforcement with integrated threat analytics. All right, so we create a simple way of doing this. We also can do it at multi-gig speeds across 100,000 workloads or more for the private and public cloud. So that gives us its scalability or scalable architecture, right, across the board. We have a secure architecture where we're able to do full layer 4 to 7 policy enforcement. We're able to do that with detailed threat analytics across great scale. Those are the benefits of the vArmor distributed security system and our ability to do application-based microsegmentation with SDN or without SDN for the private infrastructure as well as the public cloud. Thanks for joining. I'm David Anderson.